So let's open the 3D finishing model. So I'm going to close that now. Close out of that. And if we come back to 3D finishing here and open up this model here. Yep. So just like before, you can see now there's some extra operations that have been put in here. The boring the holes and stuff. And if you wanted to see all the strategies, you can click on it, each one, and you give an indication of the tool paths and what's happening at each stage. So once again, to apply this 3D finishing, I'm going to go into the 3D tab. Now we've got quite a number of operations here that we can select. The one that I'm going to use initially is the parallel finishing, where the tool is going to move up and down in a parallel direction, and just move from one end of the stock to the next end of the stock as it's going along. First thing, we need to check out, we've got the same tabs up again as before. If I go select, yeah, this time I'm going to change my tool to the 1/2 inch ball end mill. So we've got here 1/2 inch ball end. All the information comes through, press OK. This updates all this information here with the speeds and feeds. And we're going to, one thing with these boundaries, right, sorry, let me just get my head around of what I'm going to talk about now. Right, so what it is, we need to now go to the geometry tab. Yep. I'm going to select my option to selection. So in here, I'm going to select my option. We've got boundary box here. We've got silhouette. We've got selection. Different. So I'm going to click selection. And selecting the machinery boundary of the element, the inside and outside of the handle. So what I've got to do now is select the inside of this, the boundary of it, so it highlights yellow, and then the outside. But I don't want all this. This is not the outside boundary, so if I click it again, I've selected that. Can I select that one line? And it might be that I have to go around and select each one of these. Come on, there we go, got that one on. I'm just going to work my way around this model. I don't know why it didn't automatically select, but there we go. Just going to work my way around this. Let's just move this around a little bit there. Got that one. I'll select that. Got it. And then we need to come into this bit here. I need to select that. There and there. So we've actually now got all of them sections around it. There. So if I click plus, that will add now the outer boundary. So we've got the inside the handle and we've got outside. We want to make sure, or we've made sure, the contour is closed, but it could be open or closed. But on this one, we're going to make sure that it's closed. Now, one thing I would like to do is set the tool containment here to be outside of the boundary. So that's meaning that the tool will not go inside here and cut the stock. So it's always going to remain outside. So the tool can go outside of the boundary. So the tangency of the ball end, or the cylindrical surface of the ball end, is allowed to go outside of that boundary in order to cut the geometry. You can restrict that, holding things in or not. I would like to select a few faces to avoid. So what we've got here, down at the bottom, we've actually got, we put in here faces that we don't want the tool to touch. So I don't want it to touch this flat surface here, that one there, this surface here. And if I just twirl this round, I don't actually want it to touch that surface or that one. So we can actually, that can actually be, because it's actually avoid or touch surfaces. So the option there is, you can actually say, I want you to focus on this surface and these surfaces, so touch these surfaces please. Or you can actually have it the opposite way around and saying, I do not want you to touch these surfaces. So the way that this is set up at the minute is I don't want it to touch these surfaces, I want it to avoid them. So that's why I don't want it to touch them. So that's the way that I've set it up. On the passes tab here, the step over is currently set to 1/4 of an inch, which is not very fine for a finishing pass. So what I'm going to do, I'm going to change that to 0.05 of an inch. I want to set the pass direction. The pass direction is the direction that the tool is going to move. So when I look at the contour, the pass direction is based on X. So if I want to make this tool path, the tool would be going back and forth on the X-axis. Because it's a parallel tool path, it will move in a parallel fashion. But really most of the contour, most of this contour is in this direction, which is in the Y direction. So I'm going to set my pass direction to 90 degrees. So rather than it be going up and down this surface, it's going up and down in the Y direction. Then I'll tell it to go ahead and put a tick in the machine the steep edges. So we've got machine steep areas there. Then finally, let's go to the linking tab. And to save a lot of tool travel, because a lot of the material will be down at the base level, I'm going to tell it to go to minimal retraction. So here, rather than 4 retracts, I'm going to go minimum retract. So let's say OK, and let's have it develop that tool path. So you can see now it's working away here. And it's now created that tool path there for us. All complete. If we want to look at see how it's finishing now, if we're going to setup, go into simulation, keep the same settings I had before, press play. There we go. Fast forward it very quickly. So you can see now how this is starting to machine out my design or my model. So that's all the roughing, the counterboring, and this is now our first finish pass. Now what I'm going to do, as it's going through here, you can zoom in, and you'll notice you can actually see what the tool has left, the sort of grooves that are in there. So that's actually going to take quite a bit of finishing when it's done to get it all nice and smooth. So another thing that we can do is we can actually send another pass. We can actually duplicate it. So let me just close this simulation a minute. And what I'm going to do, if in this parallel path here, I right click, I can duplicate. Then if I click on it, right click and edit. I want to keep everything the same tool, the same geometry, same heights. The passes though, rather than being at 90 degrees, I'm actually going to put that at 45 degrees. I'm actually just going to change angle, I'm going to keep the linking the same. If I OK, it's now going to run another pass of this tool, but instead of going, you can see now it's going at 45 degrees across rather than 90 degrees. So it's now taking the tops off these troughs that we've done, or these peaks from the troughs. So we'll go back to setup, go to simulation, go to the end. Thing is, it can actually take quite a bit of time to do this. Come on. As you can see down at the bottom, there's actually some red little marks that are starting to appear. These are collision marks. These might be to do with the length of the tool that's being used. So what you can do, you can go down and investigate them, go back to them and see where the collision is. But a lot of the time it might just be the length of the actual tool that's being used. You might just have to increase it. And hopefully, come on, where are we up to? So it looks as though we're now we've done that first 90-degree cut. And hopefully now our tool should be starting going across doing our 45-degree cut. Because we're trying to run it through really quickly, the tool's actually not moving in the simulation. It's just showing us. Oh, stop that. Go to the end. What I want to show you is that final, how it looks at the end. Come on. Once it's actually run through the simulation once you then fast forward and rewind, it does it a lot quicker. It's when it's first computing it. It seems to take a lot longer time. But that's our 90 degrees. And again, if I zoom in, but hopefully what should happen, we should actually start seeing a checkered pattern appear where the tool's actually coming across at 45 degrees rather than at 90 degrees. I'm not sure which side it's starting on. Let's see if I can find. Whoops. I think now. Has that got a checkered effect? Yeah, you can actually see now where it's got like the cross effect, where the tool's coming across at 45 degrees compared to 90 degrees, and it's that there you go. It started to do it across here, so it started smoothing it. So it's giving it a bit more, a better finish and less work that's going to have to be done on it. So the final thing that I want to do is I just want to run one more toolpath on this that I want to apply this time. I want to keep the same tool, the same geometry, the same boundary conditions, the same everything apart from the technique to cut it. So I can't just simply duplicate. So what I can't do, let me just close that now. What I can't do is just like we did on here, is duplicate. I can't just simply do that because I'm going to be using a different technique. What I'd like to do is, or what we can do is tell it I'd like to create a derived operation. Now, one thing about derived operations is you can't have a 2D toolpath drive a 3D toolpath from it, or vice versa. You can't have a 3D toolpath drive a 2D toolpath. It has to be from a 3D to 3D toolpath or a 2D to 2D toolpath. So here, I want to change from creating another parallel to creating a scallop toolpath. So if I click on this one, right click, and create derived operation, 3D milling, and go to scallop, there, I'm keeping everything else the same. So if I just go OK, and that will now create a scallop, and it's the, if we look on here, and hover over the sculpt, you can see the type of tool path that it will go. It will follow around the shape. And that's our final pattern that we've done. So you can see how this toolpath works. Its way around the geometry. So if I was just to simulate this bit here, and I just took the full stop. I'll just close that. Looking at the time. So you can see how this will actually just follow around the actual contour. The final bit now. So we've got this now. We've got our machining paths there. But again, you're going to be able to work with your customer and help them understand what's possible and works for them. So now that the tool paths are done, we're able to go back and start taking a look at the outputs. So if we go back to setup in here, we can get the setups and the setup sheets. So up at the top, we've got setup sheet. So if I click setup sheet, it asks where do you want to save it. So if I save it in here, give it a name, sheet 2, and then select folder. Hold on, okay. I don't need a folder, it's already in a folder there. Just press select folder. And what happens is it will bring up that tooling for me. It will bring it up in a separate window. And there we go. So straight away for this one now, it's telling us our work coordinates, our stock, the tools that we're going to be used, the setups for each tool, the operations as we go down. So you can give this to your tooling room that can set up all the tools ready for you, for your machining. And then finally, what I want to show you as well, so I'll just do that, knock that down, is we've got our post-processing operations. So you can go to setup, you can set up for your machine, so you can set up for your post-processor that you'll have. You can pick, so on this one I've just got to set it up as a Denford machine. You folder where you want to save it to, program numbers. If you press post, select a number for it. So I'm just going to select that one, save, replace. And then that's now creating my G codes. And there we go. This is then all our machine coding, all our encodes, all our coordinates, all our Gs, tool changes, everything's in there along with the tooling list. So as you can see, we've got the output. So all the G codes are there, all the information on the tooling changes. You can program in manual stops. You can build it in. Everything you would expect from a mature CAM program has been built into Fusion 360. So that one opportunity to be aware of, people that are using old systems in the machining workspace, Fusion is catching on really fast. There are a lot of people out there talking about it. So if you're a training center that is part of a reseller partner, go back to some of those accounts that you've have had for a while, go visit them, see the guys in the machine shop and see if they have heard about Fusion 360. If you're a standalone training center, reach out to some of those places and put the word out that there's a new tool, new tools, new technologies available, and that you're ready and able to get them up to speed on something that will make them more productive. And that